Okay, so we are starting with a passage from Understanding Our Environment. It's the Student Lab book for Fairfax County, and I just picked a passage out of the book, gave it a little bit more space to write, and it's on dissolved oxygen. So, get started. The very first thing I see about the title is clearly we're going to be learning about dissolved oxygen. In my eyes, my brain is drawn to the oxygen first. So when I think about oxygen, I think about that it's a gas. I think about we breathe it. You breathe it to survive. You need it to survive. The chemical symbol, right, we know is O2. When I see the word dissolved, I think about sugar or salt, right? Sugar, salt. And I think about it always being dissolved in water. And you can't really have, in water, I'm going to write to for science, in solution. You don't really dissolve sugar into salt or salt into sugar. That's kind of mixing. But dissolving really means like breaking down those, molecules. And really combining them with the water. And then the last thing I see is just this DO over here. So that's the initials. It's also shorthand for the dissolved oxygen. And then I know that it's a lot of scientists, when they are talking about dissolved oxygen, they'll just say, what's the DO? So I'll write science language. That's how a scientist would refer to dissolved oxygen, as the DO. I also know it's measured in milligrams per liter. Okay? So let's get started on the passage. So very first sentence looks like it says, so oxygen gas becomes dissolved in water in a number of different ways. And then I see a number. So first thing, just before I even dive into the sentence, is it says a number of different ways. And so my brain right away wants to look and find out how many different ways can oxygen be dissolved in water. And I see it looks like there's going to be 1, 2, and then 3 different ways that oxygen gas can become dissolved in water. So, and now we can actually kind of look back at the beginning of the sentence again and see that we were right. Okay, they kind of make sure to refer to oxygen gas. And then becomes dissolved in water. Okay, so we were right. I'm going to make an arrow to my water comment over there. And I'll do to my gas comment. Okay, kind of figured out a few things just by the title, what we know about dissolved oxygen. Okay, so to the first way that oxygen gas can be dissolved in water. So it says some oxygen naturally diffuses into the water from the air. So what I noticed first, and to kind of give me a clue about the sentence and what's really happening, is this one right here. So diffuses. And so we have to think, what do we know about diffusion, about the process of diffusion in science? So we know that diffusion is movement, right? It's movement. And it's movement of molecules from areas of, I'll do an arrow, an up arrow. That's how I usually, for my own notes, describe high. So from high concentration to low concentration. Okay, movement of molecules from high to low concentration. So with that being said, we're looking, the two things that are diffusing is the oxygen, or the two parts of the sentence that will be described by the diffusion is the oxygen and the water and the air. So 3 actually is what we're kind of focused on. So clearly it means that the water has, there's my down arrow again, so less or a lower concentration of O2 than the air, which would have a higher concentration of O2 for that oxygen to diffuse from the air into the water. So I'm going to make an arrow as well, so making sure we know it's from the air into the water. And I'll, in terms of like the sentence again, so I'll put arrows to from diffusion as well. So that diffusion is referring to the air, the water, and all the way up the top, the oxygen. And then last thing, naturally as well. So I think about naturally, I think about diffusion, kind of combine those together, and I think no energy. Something naturally happens, I tend to think like, oh, it doesn't have a lot of energy involved in it. It's just gonna happen. It's supposed to happen. And then I'll write passive too, because we know that's for those two. Okay, moving on to our next way that oxygen gas can get dissolved in water is it says, moving water will mix oxygen into the water from the air as it flows over rocks or as it's stirred up by the wind or waves. So it's kind of along, there's a lot of things going on in that sentence. So we'll just start at the beginning for this one. So moving water. So we just talked about diffusion and naturally made my brain think about no energy, but it being passive. But when I see moving water, I'm going to write energy. This looks like this next way definitely requires energy. It requires movement. So moving water will mix oxygen into the water from the air as it flows over rocks or as it's stirred up by wind or waves. So kind of like the 3 ways that it's dissolved, I actually see in this sentence 3 different ways that moving water can mix oxygen into the water. So I see as it flows over rocks, so that's kind of number 1. As it's stirred up by the wind, that's number 2. And then by waves, and that's the 3rd way that moving water can mix oxygen. And it still has to do with the air. So nothing's being created, it's just moving the oxygen out of the air into the water. And when I think of all of these 3 things about flowing over rocks, about water stirring up, or the wind stirring up water, waves stirring up water, I'm just going to write bubbles. Right? And I guess what we know now is those bubbles, that's oxygen gas. Okay? When it's stirred up, I think about, I'm just going to write stream and write the sound, right? That moving water sound. And I think about when I was used to work on a boat, on a really windy and wavy day, the water would be really white, be really foamy. And that's because of those bubbles, that oxygen. So that's a way that the oxygen can get into the water as it mixes up with the air. I'm going to write mix, I'm going to also write, because when I think this through, I'm going to think combine. It's combining the oxygen in the air and moving it and mixing it and combining it with the water. Okay, and our last way, photosynthesis will increase the amount of dissolved oxygen in water as plants take in carbon dioxide and give off oxygen gas as a product of the process. Phew, it's the longest one yet. So, very first thing you can see that the subject of this whole kind of sentence, or the main topic of this sentence is all about photosynthesis and how photosynthesis gets oxygen into the water. So what do we know about photosynthesis? And we kind of talked about it in the sentence, but I just want to write it for myself. So I know photosynthesis, it's about plants. Well, plants do photosynthesis, which says that it makes oxygen. Oxygen. But it's funny because we're talking about plants, but we're also talking about water. So those plants must be underwater plants. Plants that can grow underwater. That must be a very special kind of plant. What plants do I know that grow underwater? So, examples like seagrass, really pretty grass that grows, looks just like grass on land, but it's under the water. It's really beautiful. Algae, right? Like that gross hairy algae that kind of grows on rocks, and I'm gonna actually connect that algae flowing over rocks. And then one of my favorite underwater plants is called phytoplankton. They're like teeny tiny little microscopic plant plankton. And so I guess all of those underwater plants, they make oxygen gas as well. So, and they say that. So photosynthesis will increase the amount of dissolved oxygen in water as plants take in carbon dioxide. So we didn't really talk about that they take in carbon dioxide. So that's a gas as well. And I wonder where, if we're talking about water, where does underwater CO2 come from? I guess we breathe it out. So I'll say people. So I guess you could make a jump or make a prediction that if there's organisms in the water that they take in oxygen, like they'll need it to survive, and they might breathe out. So let's say organisms. I'm going to link those two. Organisms and people breathe out. So it must be where it comes from. So they take it in and then give off, so they give off oxygen gas as a product, I'm going to circle that word, of the process. Phew. So give off oxygen gas. So we knew that, right? And I'll draw an arrow for myself over here so that they make O2. I'm just going to write O2 again. And I see 2 up here. Let's write DO when we see dissolved oxygen. Help us remember the way of saying it. But this one, the product of the process. So when I think of products, I think about stuff being created. So something being created. Or if we want to be really sciencey, so we created, or we can say maybe synthesized. Like synthesis reactions mean like creating something. So something being created, and we know that oxygen is being created by the process of photosynthesis. And so that's when they say the product of the process, that process, we know from the beginning of the sentence that process is photosynthesis. And it's actually really cool, and the last thing to talk about with this sentence, talk about oxygen gas and photosynthesis underwater and those underwater plants. For me, what I think about was when I was a marine scientist, you could actually see oxygen bubbles coming up from the seagrasses in the water. So I'm going to draw myself a little picture to help me remember. So here's the water, there's the seagrass, and then it was really beautiful. You could see all these little oxygen bubbles. I'm going to draw that too. Oxygen bubbles coming up out of the grass. It was really, really beautiful. So what did we take away from this passage? So we learned that oxygen, the gas, can be dissolved, can be combined, mixed with water. And there were 3 different ways. So you could diffuse it from the air, from high concentration in the air to low concentration in the water. You can just move it around with energy, such as rocks and wind and waves, and kind of combine the oxygen with the water. And then the last way was photosynthesis, and it's increasing. So this makes me think, when we learned about that sentence, that this is more oxygen on top of the other two. So while it's diffusing and while it's moving, photosynthesis is adding even more dissolved oxygen, more DO, into the water by just doing the process of photosynthesis. So really important, one of my favorite water quality measures is dissolved oxygen.